Hi mathematicians, we are in 2.6 continuity, and in this video we're going to look at continuity on an interval. Previously we focused on just at one point, but now suppose we want to look at a whole interval I from A to B. Okay, and so to be continuous here, you have to be continuous everywhere in between A and B, and you also have to be continuous at B from the left and continuous at A from the right. So what does this mean? What am I saying? What are these words? Okay, so let me maybe we do this, and then maybe I do this. I don't know, I'm just making something up. All right. And so this will be my A, this will be my B, it's my x-axis, my y-axis, and this is my graph, okay? And so they want to know, are we continuous on the interval AB? And clearly we're continuous everywhere between A and B, right? And we're continuous on A from the right. As I travel to A from the right-hand side, it's continuous. And I'm continuous at B from the left. So since, I'll call this f of x. Since f of x is continuous everywhere between A and B and is continuous at A from the right and at B from the left, it can be said f of x is continuous on interval I. Okay? Right, so here I just want to emphasize and reiterate, we don't need the limit to exist from the left and the right here. Right? We don't need to include that part. It's okay. Right? Again, we don't need this continuous from the right-hand side. We don't have to include that part. It's okay. So let's go ahead and do example 6. And it says determine the intervals of continuity for Okay, so let's go ahead and review what is necessary for something to be continuous at on an interval. So to be continuous on an interval, everything inside the interval must be continuous, and the endpoints, if included, from the direction of inclusion. Okay. So basically I know that the only interesting thing is going to happen here is around 0. Okay, so let's go to the left of 0, right? To the left of 0, we're using a polynomial, and we know that this polynomial x squared plus 1 is going to be continuous everywhere because polynomials are continuous everywhere. They're so well behaved. So I know that all the way up to 0, we're fine. So I know negative infinity all the way up to 0, we're going to be fine. Okay, that doesn't mean that's the only interval of continuity, but I know we are fine there because x squared plus 1 is a polynomial and continuous everywhere. Okay. All right, now if x is greater than 0, so we have everything up to 0, including 0 taken care of. Now, if we're greater than 0, are there any continuity problems? Right? No, it doesn't seem like there's any continuity problems above 0, but we're going to have to investigate what's happening right at 0. Right? So let's see. We have 0 to infinity is going to be fine, right? And let's just make sure at 0, yes. So at 0, we're going to be continuous from the left-hand side. And then we jump here, right? But then we are continuous from here over. So therefore, f is continuous on and, okay, I'm not going to write it as negative infinity to infinity because there is a break here, and so this indicates the break. Okay, let's see if they have another interesting one that I want to talk about. Continuity at a point. Here's another one. Okay, so we have f of x equals 2x and x squared plus 3x. They want to know, this is for x less than 1, and this is for x greater than or equal to 1. Okay, I'm going to change this slightly. It's a problem for your book, but we're going to go ahead and we're going to define the intervals of continuity. Okay, and so less than 1, actually let's start with greater than 1. So greater than 1 and everything greater, we're using a polynomial, so we have no problems. Okay, so 1 to infinity, we are definitely continuous because x squared plus 3x is a polynomial, therefore continuous everywhere. Okay, and then if x is less than 1, we're using this expression. So we're going to go ahead and do from negative infinity to 1 like that. We are also continuous, right? And so then this does indicate that there's a break here because I am giving it as 2 separate intervals. Okay, so that is continuity on an interval.